Example 3. A police car is approaching an intersection from the north, is chasing a speeding car that's turned the corner and is now moving east. When the cop is 0.6 miles north of the intersection and the other car is 0.8 miles east of the intersection, the cop's radar detects that the distance is increasing at 20 miles an hour. If the cop is going 60 miles an hour at that instant, what is the speed of the other car? There's a lot of information, so let's highlight some of the important pieces. A police car is approaching the intersection from the north. That's probably important. And the other one is moving east. When the cop car is 0.6 miles north and the other car is 0.8 miles east, the cop's radar detects the distance between the cars is increasing at 20 miles an hour. If the cop is going 60 miles an hour, what is the speed of the other car? And this is what I want to know. So it might help to identify what some of these weird things are. So this is going to be my y value. This is going to be my x value. This is going to be dz dt. This is my dy dt. And this is dx dt. The only reason I know where those come from is because of the next part of the problem. So those you might have to go back and identify later. So the first step to this problem is to draw a picture. So if you forget how to do north, east, south, west, the one I remember is never eat sour waffles or soggy waffles or sour watermelon. It doesn't really matter how you remember it, but never eat soggy waffles is usually what I use. And like in math, we're going to go clockwise. We're going to go this way. Never eat sour watermelon. And then it repeats. So now that you have the picture drawn, you can kind of see what's going on. The cop is heading towards the intersection and the other car is heading away from it. So it makes sense that the cop has to slow down and then the other car is going to be speeding up. So we want to figure out at this moment in time when these cars are this far apart, how fast is the orange car speeding up? So it might help to draw a second little diagram where right here, this is my cop car. Right here, this is the other car. Now this helps because we know this distance is 0.6 and we know this distance is 0.8. So we need to find a formula that's going to help relate the two. So I'm going to go ahead, I'm going to call this x, and I'm going to call this y. And I'm going to call this one z, the distance between the cop and the other car. So we have x squared plus y squared equals z squared. The Pythagorean theorem is definitely going to help us. Now let's identify what do we want to find from this problem. What's the goal? The goal is to determine the speed of the other car. So we want to find the rate at which it's traveling. So we want to find dx dt, the rate at which this car is speeding up or traveling. So let's talk about what we know. Well, we know the speed of the cop, which is 60 miles per hour. This can be represented by dy dt, the change in the cop's distance, the y value, with time. We also know the rate that the distance between the two cars is changing. This is dz dt. Remember, because I called the distance between the two cars z. So now that we have our formula, let's go ahead and take our derivative. So we have x squared plus y squared is equal to z squared. And what we're going to do is take the derivative with respect to time. So we get that 2x dx dt plus 2y dy dt is equal to 2z dz td. So I'm going to factor out a 2. Get x dx dt plus y dy dt equals 2z dz dt. And now my 2's are going to cancel. So I'm left with x dx dt plus y dy dt equals z dz dt. Now all I need to do is plug in all the information I know. Well, I know x. X is 0.8. I don't know dx dt. Again, that's what I'm trying to solve for. I know y. Y is 0.6. And dy dt is the rate that the cop is traveling. Well, he's traveling towards the intersection. So he's going at a negative speed. So it's going to be negative 60. Again, that's because he's traveling 60 miles an hour in the south direction, and south is negative. Equals, now do I know z? Well, I don't know it right away, but I can definitely solve for it. So if I have this triangle, and this is 0.6, and this is 0.8, and this is z, I get 0.6 squared plus 0.8 squared equals z squared. 3.6, whoops, 0.36 plus 0.64 equals z squared. 1 is equal to z squared, so z is equal to 1. That means that at this moment in time, the two cars are 1 mile apart. 1, and again, I know the distance between them is changing at a rate of 20 miles per hour. So I get 0.8 dx dt minus 36 is equal to 20. 0.8 dx dt is equal to 56. And then I divide both sides by 0.8. And I get that dx dt is equal to 70. This means at this instant, the other car is traveling at 70 miles per hour when the cop is 0.6 miles north and the other car is 0.8 miles east of the intersection. And that's it. The main trick to these problems is coming up with an equation to relate both of them and then taking the derivative with respect to time.